It always asks that the first time, and then afterwards it's good to
So
go.
what did you do? You just said confirm
You
or
just
yes?
confirm, and then it goes.
So it's recording now, yes?
Yep.
Oh, good.
You're on.
All right. Thank you, Mr. IT guy. All right. So we're going to be in the fifth session, creation versus evolution. It's lesson 5, part 1 tonight, and we'll do part 2 next week. And I guess the way to start this out is, if you think about it, there are really only 2 scientific models. By the way, we're on the first page. There are only 2 scientific models when it comes to how did the universe come about? One's creation and one's evolution. So first, evolution. Both of these are theories, and we've talked about this before. They're both theories, and evolution, though, is what's called a self-contained theory, and that is that the theory of evolution is self-contained, which means that everything in the universe has come into being through a random process without any kind of supernatural involvement. I want to stress the word supernatural because the argument you will get from most who talk about creation versus evolution is that if it doesn't deal with natural causes, it can't be true. Well, that immediately presupposes that there's no such thing as the supernatural. So evolution itself immediately presupposes that it has to be natural, all things have to be natural, and that further these things are going to occur in kind of a random process. So this random process is explained by time, chance, and continuing natural processes. According to evolutionary theory, all living things have arisen from a single cell organism, which in turn had arisen from something non-living, such as an amino acid or a protein. We're going to talk a little bit more about that as well as we get a little further into it. But let's start here. With kind of a look at evolution, a definition. Biological evolution is the change in the characteristics of a population over time. Now, this particular slide doesn't say it, but if you look down at the bottom, what you're going to see is a very, very, very long time. Most will say 5 billion years. It's my best impression of Carl Sagan, by the way. 5 billion years. So the process has to have a number of characteristics. First, it has to be random. Second, it has to be natural. Thirdly, it has to take place over an extended period of time. What we're going to find out is part of the reason for that extended period of time is the only way you can make evolution work is by having a very long period of time. Now, creation, on the other hand, the theory of creation is that the universe is not self-contained. In other words, there's something outside of the universe that is affecting the universe. Everything in the universe has come into being through the design, purpose, and deliberate acts of a supernatural, and I'm not even going to use the word creator or God, a supernatural, intelligent designer. Now, you can call it whatever you want to. It's still going to come out God. People will use intelligent design to make the point that there is something behind this besides just random chance. But the reality is, intelligent design means God. These are the only 2 possibilities concerning the origins. One or the other can't be true. One of the 2 has to be true. It's either evolution or it's creation. We're going to see tonight an attempt by some of our brother Christians to try to make it a either or, and we're going to see kind of a feeble attempt to do that. So both evolution and creation may be called scientific models, since both may be used to explain and predict scientific facts. Now, In order to examine properly the two models, they must be defined in general terms. Evolution includes the evidence for a gradual, this is the evidence that they say there is, a gradual appearance of present life over eons of time, with complex kinds of life emerging from simpler kinds and ultimately from non-living matter. I want you to keep that in the back of your mind too. How does something come out of non-living matter? We're going to deal with that a little bit tonight as well. Creation, on the other hand, includes the evidence for a sudden appearance of complex life. We've talked about the Big Bang Theory and how the Big Bang Theory occurred. It occurred in Genesis 1:1. In the beginning was God. That's the Big Bang. The creation model denies something called vertical evolution, which is also called macroevolution, and that term came up last week. I brought it up, and I don't think it was in the Truth Project, but he may have alluded to it. Creation denies vertical or macroevolution. We're going to look at that here in just a minute, but does agree that there's something called microevolution. The difference is this. Actually, probably the best way to do it is let's look at a slide. Now, one of these, you'll notice the very top right, it has to be a misprint. This slide comes directly out of one of the ones I found, but it has to be a misprint because it just repeats what's on the left. On the left-hand side, you'll see a description of microevolution. On the right-hand side, you'll see a description of macroevolution. And the key to this is simply this. Macroevolution is evolution that is vertical. In other words, it says that you can have a dog that turns into a cow that turns into whatever it is, whatever you want to do. Whereas microevolution says you can have evolution among the species, a Chihuahua and a Saint Bernard, but it's all dog. You can have evolution within the species, but you can't have evolution across the species. And we're going to look at that some more too. Let me tell you what my good buddy Norm, you know, Norm and I are on first name basis here. Macroevolution is exactly what Darwinists claim from the data. They say that these observable micro changes can be extrapolated to prove that unobservable microevolution has occurred. Are you following me? In other words, they're saying, look, the Chihuahua and the Saint Bernard and the German Shepherd, they all evolved this way. Therefore, we can say that the Chihuahua will ultimately evolve into a heifer, and ultimately from a heifer into whatever it is. So they use microevolution to say, that's why you need to make sure, when somebody says, do you believe in evolution, ask them, are you talking about microevolution or macroevolution? First of all, a lot of them aren't going to know what you're talking about. They're just going to say, well, evolution. There's a difference. Microevolution is within a species and are changes over a period of time in that species. Macroevolution is a change across species lines. You'll notice that one of the other main differences is microevolution occur through several generations, where macroevolution occurs through a long period of time. They have longer here, but it's actually a very long period of time. Let me finish with Geisler. They make no distinction between microevolution and macroevolution, and thus use the evidence for microevolution to prove macroevolution. By failing to make this critical distinction, Darwinists can dupe the general public into thinking that any observable change in an organism proves that all life has evolved from the first one-celled creature. That is why it is essential that the right distinction be made, that all hidden assumptions be exposed when discussing creation-evolution controversy. So if someone asks you, do you believe in evolution, what are you going to say?
Which kind?
Which kind? Are you talking about microevolution or macroevolution? And I will guarantee you, half of the people you ask that question to aren't going to know the difference. They're going to say, well, just evolution. And then I've got one more one more slide here I wanted you to look at related to micro versus macro, and I think this will make it a little clearer to you. As soon as I can, that's not what I wanted. Aha, there he is. The mouse keeps jumping from here to there.
Take it out.
He needs a pad or something because he's working on smooth. There you go. And he's running off with an inch.
Darn it.
Another piece of paper give you from running off.
I don't think that's the problem, Marie. We'll try it and see. I'll put a piece of paper down there. I don't think that's the problem.
It's like your roller's not picking up.
No, I got it here, I think, Mom. Thanks. I just got to keep the mouse. The problem is trying to find the tiny little arrow on the This gives you a better description of micro versus macro evolution. On the left-hand side, a dog is a dog and will always be a dog. That's micro evolution. On the right-hand side, you can see the progression from sea life to lizard, from lizard to whatever you want, a dinosaur, a horse, a man. There has never been, and as far as I'm concerned, well, I can't say as far as I'm concerned because that would be opinion, there has never been a case of macro evolution found anywhere in the fossil record or anyplace else. Dale?
And also, if you have mutants, they're always the loss of information, supposedly not as good as the predecessor. So how do you get all of a sudden macroevolution getting better?
Well, exactly, especially when we get to mutations, what we're going to find out is there's a number of different types of mutations. Most mutations are usually bad mutations. So it's not like you mutate to a better degree. It's very rare that that occurs. So as we keep these things in mind, I want to come back later tonight and we're going to talk a little bit about something we did last week called irreducible complexity as well in relation to micro and macro evolution. But for now, keep that in the back of your mind and keep the distinction of the two, micro versus macro evolution. Microevolution can occur, and it occurs within a species or within a kind. Macroevolution, there's never been a case of it proven, there's never been a fossil record proven, there's never been any way to prove that macroevolution occurs. So what typically happens is, remember last week when we talked about a couple weeks ago, when we talked about the bird's beak, I forget what bird it was,
Finch.
the finch beak. What did we end up with after all that? Didn't we still end up with a finch?
Yeah.
So all you had was a different beak. That's microevolution.
I really don't think that was ever microevolution, to be honest with you. I think that was variation, and I think that's what they proved. Anyway, so I just wanted to make this little point. I'm trying to think of, there are probably some species that are closer than other species. We can mate a horse and a donkey and come out with something that can't breed, so that's a successful, but one of the tests, I think I doubt that that's said anymore. 50 years ago, one of the tests for a species is that it was unique and that it was capable of reproducing itself. And if it couldn't reproduce itself, it's not a species, it's something else. I
don't know what else you call it besides variation, because you have genus, species, and I don't remember, family, kind, get all the way up to phylum. I mean, there's seven steps. And I'm trying to remember where you can have variation. I don't think you have variation across the species.
Yeah, it's hard to swing from branch to branch in that tree. That's what I'm trying to say. And I hope I'm saying that facetiously. It's just the part of the definition of a species is that it's not able to mate with another species. And then as soon as you say that, then you got this mule problem. But that's one of the few things in nature, and again, it's not reproducible. So you don't have a pair of breeding mules.
Then the question becomes, is this an important deal? Well, yeah, it's got through saying the two questions you're going to get the most. That's going to be one of the preeminent questions. But is the creation versus evolution controversy a big controversy?
Should be.
Well, not only it should be, but if you think about it, in one way or another, it's a huge one. In one way or another, it touches almost every field of study and every part of life. It deals with two opposing world views. And if you don't think so, if you don't think it's a big deal, go look at even a first grade science book, if they have some type, and here's what it's going to say. Millions and millions of years ago, such and such. So it starts as early as that. So, question? Oh, so is it a big deal? It is. Now, in the book, what you've got are some surveys and some polls that have been done over the years. But if you look through these, they date back to 1981, 1991. The oldest one that's in here is 2000. And there's some pretty interesting information in it. For instance, in 1981, an Associated Press NBC News poll found that no less than 86% of the people polled wanted creation to be taught alongside evolution in public schools. That's a 1981 poll. Now, unfortunately, I don't know how dated this material is, but what I did was go look at some more recent ones, try to pull up some recent ones to give us an idea of where people fall in this in the whole issue, and it is a big issue. This particular poll was Gallup over a period of time. I don't know what the first year is, or 1983, I think, from 2019. You'll notice a couple of interesting things here. The first is this. The kind of gray line is that God created humanity in its present form. That's creation. Can you see the top line, the gray line? Then there's a black line down at the bottom that is basically everyone here believes in evolution, right? What's the green line?
Percentage of humans involved.
God's guided.
God guided, but they believe that God guided, but there's something more going on. I'm thinking, when I first saw this poem, I'm going, well, what else could be going on? Well, we'll talk about that here in just a minute. But here's what I want you to notice out of this, and then I'm going to pull up a couple of other polls. I want you to notice that in 1983, 9% of the American public believed in evolution. 2019, it's up to about 22%. So it's risen a little bit. Frankly, not as much as I thought it would have, and I'll tell you why here in just a second. But if you combine the two numbers of God's involved or God did it all, it's 73%. That surprised me. 73% of the country says either God created everything or God was involved in creation rather than evolution occurred. So what is this kind of middling position, and how do you end up there without being a Methodist? Sorry. There's something called theistic evolution. And let me tell you what theistic evolution is. Theistic evolution is an attempt by Christians who've been confronted with what they think is this proof of evolution to try to find some middle ground to say one of two things. Either God created the building blocks and the natural laws with the eventual emergence of life in mind. However, early on he stepped back and let his creation take over. Has anybody ever heard of the concept called open theology? Open theology is pretty much the same thing. Open theology is there was a God, he created the world, and then he's hands off. He doesn't know where it's going to end up. He doesn't know what's going to happen with it. That's called open theology. The concept that they usually use is a top. Someone just spinning a top, not knowing what's going to happen with it. The other type of theistic evolution is God performed constant miracles to bring about the origin of life as we know it today. In other words, he was involved in creation and he brought about miracles of some type, maybe Adam, and according to this view, he led life step by step down a path from primeval simplicity to contemporary complexity. But the point is, both of these still allow for some type of evolution. That's how you end up with that group that says God's involved, but there's more to it.
And yet scientists know you can't go from simplicity to complexity without an awful lot of energy input.
You know, I told Deb the other day, I have trouble with this because everything I read, people are going to great extents to try to, I mean really great extents. Last week we talked about punctuated equilibrium. We'll talk about that again tonight a little bit. To try to make something that seems so simple so difficult. And there's only one reason. I don't want to believe there's a God. That's simplistically, that's what it is. Now, I wanted to look at just a couple more poll results that you might find interesting. You want to know how you stand out in terms of religions? Belief in evolution by religious tradition. First of all U.S. adults, all mankind existed in its present form. That's the kind of green line. Evolved, guided by God or a higher power. And then finally, evolved due to natural processes. Interestingly, white evangelical Protestants, not overly surprising, say 38% that man existed in the present form from the beginning, which is creation. But look at those who say evolved, guided by God or a higher power, 58%. Doesn't that struck me as, well, I was flabbergasted, to tell you the truth. You can look at the rest of them. This is from the Pew Research Center in 2018. I want to show you one more poll that I think you're going to find fascinating related to this, and that is this. If you were to, let me just ask you this. Now I'm going to put this in the frame of a declaration. 98% of all scientists believe in evolution.
That's true or false.
Who said false?
I did.
Why did you say false?
Well, because I've seen that just in experience that there are a lot of scientists that believe in creation.
But I don't know the numbers. I mean,
But I don't, yeah.
Would you like to know the numbers? You'll be surprised. All scientists, 33% believe in God. 18% who don't believe in God, but do believe in a universal spirit or higher power. Okay, what do you want to call it? Jimmy? Well, I don't care. Call it whatever you want to call it. It's a higher power. 41%, and this is all scientists, 41% who don't believe in either. And then 7% that don't know or refuse to answer. Let me show you where I think the most important part of this whole thing is. These are scientists, by the way. This is a poll of scientists. This is Pew Research again. I think I put down one. Oh yeah, June 2009.
Interesting, younger ones more believe.
That's the point. I want you to notice something here. Look at, oops, I just took my little cursor off and I'm going to have trouble again. Look at the age groups. And what do you see?
Younger ones are learning.
Well, you'd think just the opposite, wouldn't you?
Yeah.
Because if you look at the age 65 people and younger, it's just before the boomers that this started being force-fed to every child in the nation under public education. And it's interesting that we've been pouring garbage in, and garbage may not be coming out. So I think that's an interesting. That's like a hopeful statistic.
Deb, maybe I'm going to need a mouse pad. I was doing fine until I moved it. You guys got me so excited. Look what happened.
The mouse jumped right off.
Well, while she's doing that,
Got
here's,
him back.
pardon?
Got him back. He's on 65 plus.
Yeah, there's your person.
Yeah, the problem is he needs to be on the computer.
Oh,
He won't do any good over here. That's the, see, when you have multiple screens, you can move from screen to screen, but the cursor needs to be here in order to do any damage or control. Anna, come up here and see if you can find this cursor for me. You've had to do this before.
Do you want to do the pad first and then?
Yeah, let me try the mouse pad. Thank you, dear. I'm gonna have to see if, you know what we need to do is, there we go. Oh, that did help. You were right, Marie, that did help.
Too slick over there.
So, I'm gonna have to have Alexander come up with bifocal mice. So back to the point, Dale, is that when I first looked at this, I was, first of all, surprised by a third of the scientists. Now, this is all scientists. Now, I will tell you this. You will see a number that says 97% of these scientists believe in evolution. Well, keep looking, because it's going to be, and I forget the association of it, but they polled the association of such and such and such and such. 93 or 98% of them do. This polled all scientists. Now, I can't tell you the universe they used or how they went about it, but this poll said all scientists, and you can see the breakdown in field of study, chemistry, geosciences, biology. Look at biology and chemistry together, which would be the two most important for what we're looking at. I was amazed to see the number of scientists who believe in creation, or at least some form of creation. But the thing that I found the most encouraging, Dale, and you put your finger right on it, look at the age groups, 18 to 34, 42% and 24, if you combine those, that's 66% of younger scientists are saying creation, there is something behind creation. Now, here's the reason why that's important. 1981, the National Center for Science Education was founded. Guess what the first thing was the National Center for Science Education did? Excuse me. They said evolution must be taught in all schools. That was 1983. One would expect two things to happen. That first poll we looked at, it showed that there wasn't much of a gain over the last 30 years to like 22%. You would have thought that would have skyrocketed. Secondly, you'd have thought this group, that group of 18 to 34-year-olds, would have said, well, of course it's evolution. Because why? What have they been taught?
they've been taught evolution.
That's exactly what they've been taught. And the only thing they've been taught.
Yeah.
So the results are unexpected by evolutionists who would have expected most people to believe in evolution since it's being taught as a fact. Now, even scientists today who claim to be evolutionists will say, will recognize creation at least as a legitimate scientific concept. So if you think about that, 150 years of Darwinism, rapidly growing numbers of scientists have become convinced that natural laws and processes that we now know absolutely exclude the possibility that the universe could have created itself. So at least scientists are beginning to say, what Dale said all along, how can you possibly be a scientist and fly in the face of everything that you're seeing in front of you? We're beginning to see that. I think there's still a major road to hoe.
Yet the book's still evolution.
We'll look at an example of that tonight. Now, if that's true, what's the credibility? Is there a credibility for the creation model? Is there something behind it?
Oh, yeah.
Okay, then we're done. We can just finish.
Not according to Dawkins.
There's a number of things, and we're going to deal, but we're just going to look at three of them tonight. And the first of them is something called the law of biogenesis. Now, has anybody ever heard of the law of biogenesis?
The law of the beginning of life. Is that what that means?
Well, we'll look. Biogenesis. The principle that living organisms develop only from other living organisms and not from non-living matter. Let me finish, Dale, and we'll come back. That's the first thing. The second principle is this: generation of living organisms from other living organisms. This goes all the way back to Louis Pasteur in somewhere in the mid-1800s. Dale?
I believe it was Miller who created life from non-life. By passing an electrical charge through, I forget the atmosphere he used, but it wasn't oxygen. And supposedly he got a life that existed for a second or two, and it was later, though, totally discounted, but I'm surprised I haven't seen anything about that in recent times.
Yeah, it was discounted for two reasons. One, he had to apply something in order to make it happen. He had to apply electric current in order to make it happen, right? And I'm trying to remember the second reason.
Well, the atmosphere was totally foreign to anything, that would exist with our kind of life.
That was the second thing, is he had it under, if he had used the atmosphere that we're in, with the percentage of oxygen, nitrogen, if he'd used our atmosphere, it never would have occurred.
Right.
And it only lasted, it was instantaneous. That's the only time anybody's ever even claimed to do it. So from that point on, or actually, prior to that point, back into the 1880s, and we're going to look at another slide of it here, Louis Pasteur and Reddy both did experiments, pretty crude experiments, but you're going to see them here, that prove the law of biogenesis. So this law set forth many years ago to explain that what both theory and experiential evidence showed to be true among living organisms, that life comes only from previous life, I want you to listen to this, of its own kind. Okay? Now, in fact, the law was established firmly in science long before modern evolutionary theories were invented. Louis Pasteur's work on the false notion of spontaneous generation, which we're going to look at here in just a minute as well, which is the idea that life arises on its own from non-living sources. Students are presented in great detail the history of how Pasteur triumphed over mythology, providing science with its finest hour as he disproved the popular concept of spontaneous generation. I told you we'll look at that. Then, in almost the next breath, as Dale said, students are informed that the evolutionary process began as a result of spontaneous generation. This is the same class that says, that is being taught the law of biogenesis. In nature or in the laboratory, scientists have not documented a single case of spontaneous generation. Cows give rise to cows, birds to birds, tulips to tulips, corn to corn, and so on. So what are these two things we're talking about? We've already talked about the law of biogenesis. Here is kind of the crude experiments that were done to prove it back as early as 1668. And you'll notice that they are crude, but they do the same thing. The top one, just a piece of meat was put in a jar. And guess what? Life formed. Anybody ever seen a maggot?
No, boy.
Not a single one.
Yeah, that's right. That's right. Anybody ever seen
maggots?
That's right. You never see a single maggot, do you?
I don't know. I mean, maybe I did and I didn't recognize it.
So in the first picture, there's nothing on top of the jar. Second picture, it had gauze covered over the jar. Flies couldn't enter, but they laid eggs in the gauze that hatched maggots, or eggs fell through the gauze. Look at what happens in the third picture. What happens? It's sealed. In other words, nothing can get to the inanimate, dead piece of meat in order to produce life. The experiments usually used, though, is Louis Pasteur's, where he took a beaker of broth, and he boiled the beaker of broth, and he left it open. Well, guess what occurred? Microorganisms got inside, and why wouldn't they? Got inside, and what occurred? Fermentation. Yeah, fermentation, but life. In the second one, he took a cotton plug and filtered bacteria from the air entering into the flask, it remained sterile. But the one you usually see used is the third picture. Bacteria were removed from the air entering the flask by settling in the long neck. In other words, what would happen is you put a long neck on the bottle, it would naturally form what's called a trap, where nothing could get through the trap, and guess what? It's completely sterile. The point being, there has never been an occurrence, and these two experiments, these are still used to prove the law of biogenesis. Now, I will tell you this, recent years, some evolutionists have complained that the law of biogenesis is not a law at all, but merely a principle or a theory or a dictum. The problem is, no one's ever been able to find a single documented case of spontaneous generation like this, like what they're talking about. The fact is, every shred of scientific evidence still supports the concept that life arises only from pre-existing life. All right, so that's the first concept. The second concept is this, natural selection. By the way, anybody know the name of Darwin's book?
Well, it's The Origin of Species, or the, I can't remember the long title, but natural selection that leads to higher organisms or better.
Yeah, the title is, and you've hit it, the title is actually this. Most people will just say The Origin of the Species. Actually, most people won't even say that because they don't know it. Most people will say Darwin's theory. Here's what the title of Darwin's theory is this: The Origin of Species by Means of Natural Selection. That's the title of the book. In other words, he's saying that it's due to natural selection that the species have originated and have grown to where they are right now. Here's what Darwin said, and I'm going to quote him. Natural selection is the daily and hourly scrutinizing every variation, even the slightest, rejecting that which is bad, preserving and adding up all that is good, silently and insensibly working at the improvement of each organic being. I want you to think about that for just a minute. What he's saying is each organism makes the determination whether what's going to happen to them is bad or good. They get rid of the bad and keep the good. How much sugar did you eat tonight? Were you making the right decision when you ate? Did you get rid of the bad and keep the good?
Ate it all.
See?
It's all good.
And it's certainly no secret that Darwin's concept of natural selection was survival of the fittest, as it has come to be known and has been at the center of evolutionary thought. By the way, I don't remember if you guys remember a couple weeks ago, my good friend Greg, who's not here tonight, my good friend Greg said Charles Darwin never used the term survival of the fittest. He didn't. One of his acolytes who came after him, a guy by the name of Herbert Spencer, did, but the concept was definitely there. Natural selection means what? The one who is the most fit is going to survive. Let me give you an example. A horse with long legs, for example, is going to be able to gallop faster than the rest of the horses, right? Let's take, well, here's what we'll do. If you don't think that's true, I'm going to enter, the Preakness is coming up this week, right? I'm going to enter a Shetland pony. What do you think is going to happen?
He's gonna kick you.
You're gonna lose.
Yeah. Well, I don't know. I'm going to drug mine, but yeah, that's a true point. So what is a horse with longer legs who's faster is going to be able to do what? Outrun anybody who's going to prey on that herd of horses. What's going to happen to my Shetland pony?
Be left at the starting line.
He's going to get eaten, right? So which one is going to survive, right? But here's the problem. The problem with natural selection have developed. Somehow natural selection was supposed to ensure that survival of the fittest, But the only realistic way to define the fittest was those who survived. This is called circular reasoning, by the way. Basically, then, natural selection says simply that all the winners win, and those who win are winners.
I'm a winner!
Yeah, that's right. But what it doesn't do, it doesn't explain how the species adapted or how different life forms were created to begin with. We're still talking about horses. Are you with me? So natural selection then does give you the survival of the fittest. That's true, but it never tells you how they came to be to begin with, or how they came to be the most fit. That's the second line of reasoning. The third line of reasoning is this: genetics. One of the newest and certainly one of the most exciting sciences is that of genetics. And we talked about that a couple of weeks ago, DNA and RNA. Let's see, hold on one
My
second.
husband would have eaten this alive. He loves science.
Now,
God, this stuff.
studies have shown that the hereditary information found within the living cell is placed there in a chemical code, and that this code is universal in nature. Do you remember the DNA that we looked at, 3 weeks ago or whatever it was, and that within each cell, I don't remember if it's in each cell or in the body, there's enough information for 3,000 volumes of the Encyclopedia Britannica, that much information is stored there, each cell. Even to the point that British evolutionist Richard Dawkins noted, the genetic code is universal. The complete word-for-word universality of the genetic code is too much of a good thing. Creationists agree. Darrell Kuntz, for example, wrote, "It is recognized by molecular biologists that the genetic code is universal, irrespective of how different living things are in their external appearance." Now, one of the most important points in regard to genetics, so far as creation evolution is concerned, is that the genetic code's chemical instructions are copied faithfully time after time after time. Buttercups produce buttercups, sparrows produce sparrows, human beings produce human beings. It's copied over and over and over. Now, at the turn of the century, just as the Darwinist dogma of natural selection was beginning to fall on hard times, the science of genetics was born. Some who began to study genetics felt that they had found the actual mechanism of evolution, which is genetic mutation. So now, when it used to be natural selection, guess what happened around the turn of the century? Oh, no. It's actually natural selection plus genetic mutations. Is everybody following me? Now, what is a genetic mutation? Genetic mutations are slight alterations of DNA or RNA nucleotides, genes or chromosomes that may occur during replication or cell division. They are random, uncorrected errors and may be beneficial or harmful in a relationship to evolution. Well, what exactly does that mean? Well, let's look at that as well. In other words, evolutionists soon realized that natural selection alone was not adequate or sufficient mechanism, and organisms would need to change from one species to another, would not change from one species to another unless genetic material was changed. Mutations are changes passed through the parent to offspring caused by variations of the original genetic material. There are some problems with it. And let me tell you what those problems are. Before we do that, let's look at what that means. Do you remember when we had, the picture on the left is our original DNA? Do you remember that? Well, a mutation is when the chain is broken somehow. This is one type of mutation. When the chain is broken somehow and the genetic code doesn't line up, right? Well, 3 things you need to remember about mutations. First of all, they're random. You can't ever get them to replicate the same thing. Secondly, they're rare. And thirdly, good mutations are very, very, very rare. You only have 3 mutations, 3 types of mutations: a good mutation, a bad mutation, and a neutral mutation. We don't really care about neutral ones, do we? Because they don't have any effect. So, what then may be said about the bad or good mutations? Of the remainder of all mutations after neutral ones have been eliminated, 99% are harmful, considered, for example, the following. I'm going to give you 3 types. Mutation, well, first of all, mutations are random. These aren't types of mutations, these are characteristics. There's no way to control mutations nor to predict with accuracy when they might occur. In other words, nature is not selecting at all, rather nature must simply accept whatever occurs. The second is, they're very rare. How often do random mutations occur? One scientist said it's probably fair to estimate the frequency of a majority of mutations in higher organisms between 1 in 10,000 and 1 in a million per gene per generation. You know how infinitesimal that is? And it's got a pretty big margin of error. It could be anywhere from 1 in 10,000 to 1 in a million. That's a pretty big variation. Now, the third thing is, good mutations are very, very rare. In theory, there are at least 3 types of mutations, as we've said: good, bad, and neutral. How often do good mutations occur? Hermann Mueller, a Nobel laureate in genetics, said this: accordingly, the great majority of mutations, certainly well over 99%, are harmful in some way, as is to be expected of the effects of accidental occurrences. So however many there are, 99%, according to him, are bad. So what's the conclusion? Genetic mutations may create a weaker plant or an animal or a human, but they never created a new kind of animal. All they created was a variation or a mutation in the kind or the animal that was there. And mutations are mostly destructive and cannot provide a reasonable mechanism for evolution. The genetic code, with its complexity, orderliness, and function, provides the most powerful kind of evidence for intelligent design, which requires what? If you have an intelligent design, what do you have? You got to have an intelligent designer. Now,
do you know of an example of a good mutation? I can think of bad, but I don't know any example.
You know, I looked for some, and I couldn't find anything. There probably is, but I couldn't find anything.
Well, I was just trying to think of what a bad mutation would be, and the first thing that popped into my head was Down syndrome.
Yes, mine too. I wondered about that.
Is that a mutation where from birth there was a defect in the DNA structure that caused the Down syndrome?
Is that a mutation or just a different DNA sequence?
Yeah,
That
I
part
don't
of
know
it-
if I would call that a mutation.
You can have recessive and dominant genes, and and those are not mutations, they're just recessive and dominant genes, and you get you team up all the recessives in a offspring.
I don't want to get too much into the biology. I was just trying to give an example. I'm not sure that was a good example.
I'm not sure.
I can't tell you.
About a defect or a structural change in the DNA, and it's like when you go back to that irreducible complexity, when you change one component of it, it never works the same.
You know, Elliot, I'll do a little research on it, but I'm going to guess not, and I'll tell you why. Mutations are, as we've talked about, random, and they rarely occur, and if they are random, they don't reoccur. So there's something that in Down syndrome as an example, can reoccur from generation to generation. So there has to be something else that addresses that, and I can't tell you what it is.
Too deep into biology.
Yeah, the only thing the internet says is examples of mutations in animals are those born with extra body parts. For example, two-headed snake, four-legged ducks, a cyclops kitten. Often these kinds of mutations lead to the death of the animal soon or a few days after its birth.
We
What
act-
about people that have extra toes or in humans?
We actually had one in our study of David, and Marilyn was disappointed that we didn't talk about it. There was, we didn't deal with it, but there was one of the warriors had 6 fingers on each hand. Do you remember that?
Yes, I remember that.
Yeah.
Well, that could have been a descendant from a Nephilim then.
Oh, that's, actually, he was very tall too. Now, there's a couple of other things, but I think I want to stop here tonight. I wanted to deal, we'll pick it up next week, because so far there's been a lot here, hasn't there? So I want to come back and pick this up next week, but I wanted to deal with irreducible complexity a little bit more, and then something called non-viability of transitional forms. And then finally, molecular isolation. We're going to talk about those 3 things as we kind of wrap up next week in this whole thing, this whole study of evolution versus creation. Questions, before we start? Oh, by the way, I've started a list here of those things that we've talked about that we want to get through that will come up that we haven't yet. One is radiometric dating, which is also carbon. That's carbon-14 is one type of what's called radiometric dating. The fossil record, we've talked about the fossil record and gaps, huge gaps in the fossil record, because a lot of people who believe in evolution will say, oh, it's in the fossil record. You're going to be surprised at what is and is not in the fossil record. There are some huge gaps in the fossil record. So we'll come back and deal with that too. Questions?
I just wanted to mention
sorry.
there's a movie that Ben Stein narrates, and probably a lot of you have seen it, Expelled.
Oh, yeah.
And it talks about different scientists that are creationists or that at least don't believe in evolution, and it's got some good information in that, if I remember correctly. I was looking it up on my phone because I couldn't remember the name of it, and it said it's like a propaganda movie.
I remember that. I enjoyed it. Wait a minute. Wait, hold on. I enjoyed the movie. I thought it was very good. Bueller. Well, why don't we wrap up tonight then, and I gotta quit. Stop it.